Hello everyone. So in this video we are going to discuss the 2023 question paper of Delhi University for the paper Ordinary Differential Equations BSc Honours Mathematics. This was the first time when NEP examination was conducted under the new structure, the NEP curriculum. You can see that the choice pattern of the paper is the total marks are 90 and every question has got 3 parts, out of which you have to attempt any 2 parts, and each part is carrying 7.5 marks. So that makes it 6 questions, 15 marks each question. So 15 into 6, that makes it 90. And you can see that the use of scientific calculator, non-programmable scientific calculator, is very much allowed in this examination. So let's quickly flip through the question paper. I'm going to give you hints for every question here and there. You can see that the first question is an initial value problem, a standard question from your textbook. It's a Bernoulli equation if you put it in that form. It's a Bernoulli equation, and putting v equal to y square is going to help you in solving. Do not forget that it's an initial value problem, so in the end, in the general solution, you have to find the value of c also. So that means you are in a lookout for a particular solution, and after doing everything according to the procedure of Bernoulli, you're going to get y square e to power 2x is equal to 2x square plus 4 as the final answer to this question. Moving on to the second part. If you look at the second part, again a standard question from Ross. So it's reducible to exact, which can be done using the rule, which is rule 2. Del n by del x minus del m by del y upon m is going to be just a function of y. So you can find the integrating factor as cos y and just multiply the equation throughout by cos y and find the answer. Towards the end, it's going to become exact after applying rule 2 for making it exact, and the answer is going to look like this. Moving on to the third part. The third part, C part of the first question, has got 2 components. The first component is straight away an exact differential equation, very easy to solve. You do not have to worry about it. At this stage, whenever the equation is exact, you know that the solution is a one-liner. There's a standard procedure for solving exact equations. And the second one, it's reducing the order. So you can see that here the independent variable x is missing. It's that type. So you can just put y dash as p and write y double dash as p dp by dy and so on. So that standard procedure is going to help you in getting the final answer to this question as this. So you can verify the details on your own. Now moving on to 2a, there's a certain rumor which began to spread, again from Penny. It's a standard question. Rumor begins to spread, and the assumption is that the rate of increase of the number of individuals who have heard the rumor is proportional to the number who have not heard it. So you can see that the equation is going to be dx by dt is k into the total figure, which is around 1 lakh, minus the number who have heard it. So this is the equation which will be followed, and using the given conditions and so on, you can see that it is easily solvable. And the question is, how long is it going to take until half the population hears the rumor? So it's going to be, the answer is going to be approximately 46 days. You can verify. Again, a standard question from Edwards and Penny. Look at 2b, again a question from Penny. Half-life of cobalt is given, and you are given some condition. And if you use the law of radioactivity, which says that dn by dt is minus kn, using that law and using the normal calculations, your answer is going to be around 35 years approximately for this particular question. The third question from the third part from the second question is based on Newton's law of cooling. Again, it's the same question, which is as it is in the book. The figures are the same, so you can easily use Newton's law of cooling. dt by dt is minus kt minus 70, because temperature of the surrounding medium is 70 in this case, and using the assumptions given here, you can easily verify that the temperature will be 100 degrees Fahrenheit in approximately 66.5 minutes. You can verify the details yourself. Now moving on to question 3 of this. Question 3 is based on unit 2. So the division of the questions is also according to the units. So the first 2 questions come from unit 1, the next 2 questions come from unit 2, and the last 2 questions come from unit 3. So look at 3a, you have to show that these solutions are linearly independent. You know, you can show linear independence by considering their Wronskian and showing that the Wronskian is non-zero. And then since you have to find one particular solution which satisfies some conditions, you know that if there's a third order equation and you know 3 linearly independent solutions, then the general solution is given by their linear combination. So you can just take the linear combination here, and after doing that, you will use the conditions which are given to find the values of C1, C2 and C3. You will find that C1 turns out to be 1, C2 turns out to be -3 and C3 turns out to be 2 after applying the conditions. So your answer becomes x minus 3x square. No, so it's going to be C1, so it's going to be 1 into x minus 3 into x square plus C3, so that's equal to 2 into x log x. So that's the answer to this question. And after doing this, so you can verify these constants on your own. After this, there's a question, an expected problem. Variation of parameters and undetermined coefficients is always a short question in this exam. So it's a standard question. Once again, for variation of parameters, we know the standard procedure. We have to first calculate YC and then YP using the formula which we know, and the answer one can verify, though it's a question which is a standard question from the book again, but still I am writing the final answer for you to verify that the YC component will be this and YP component can be verified to be, this is log of sec 3x plus tan 3x. So you can verify these details yourself using the standard methods. The next question, as expected, every time in this part you will get one question from undetermined coefficients and one question from variation of parameters. So this is a question from undetermined coefficients, for which you will first calculate YC. YC will be having the roots of the characteristic equation will be 0, 0 and 1, and therefore since it's 0, 0 and 1, it's not a standard case, it's a modified, it's a special situation where your trial YP will be modified. So you know that trial YP will be modified to instead of normal a e to power minus x will remain a e to power minus x, but for 3x square, instead of 3x square, you're going to multiply it with 2 powers of x to power 2, because there's a 0 coming with multiplicity 2 in the characteristic equation. So this is a standard way of modifying. So you will call it at bx4 cx cube cabc ex square, and then the other ones you do not have to take because they'll already be a part of YC. So you can try this trial YP, and YC is already known, so YC plus YP is going to give you the final answer. Let me write the final answer for this question, which I have calculated. The final answer will be C1 plus C2x plus C3 e to power x minus 2 e to power minus x minus 3x square minus x cube minus x4 by 4. You can verify that the constants turn out to be this in this question. Now the next question is operator method question. So you know how to do operator method question. You will write this in operator form as 2d plus 1 of x plus d plus 5 of y is 40. This equation where d is the operator which differentiates with respect to t, and here this equation will be written as d plus 2 of x plus d plus 2 of y is equal to 2. So you can eliminate one of the variables first and then use that variable's answer in one of the equations using your own wisdom, whichever is easier to handle to get the other variable. So you can easily handle this question, again a standard question. Next part is Euler equation. You can see it's Euler's equation which we have done in great detail. This is done if you put b as log x, this simplifies. So it's not just a homogeneous one, it's right hand side is non-zero. So be very careful while you find out your yp here, because the component here is not just yc, it's yc plus yp, because the right hand side is non-zero. So you'll have to make sure that you are calculating yp nicely using the standard techniques that you know, either variation of parameters or undetermined coefficients. So you can verify the final answer yourself. Look at the third part. Third part is a standard question again. So the paper was quite standard. All the questions were straightforward. No change of data, no change of figures. There's a body with mass half kg attached to. So this is from simple pendulum. Standard formulae are there. Your k is 16n by 2m, so it's going to be 8n by m. So your equation, circular frequency you know is under root of 16 here, and time period is going to be 2t by omega naught. So standard formulae are going to give you the final answers to these questions, and the period of oscillation. All this is standard, everything is given, so you just apply the formula to get the final answer. Now look at the fifth question. You have to determine define the, so fifth question obviously falls in unit 3. I told you that it's unit wise scheme. The first two questions come from unit 2, the third and fourth question come from unit 2, first and second from unit 1, third and fourth from unit 2, fifth and sixth from unit 3. So this is the beginning of unit 3, which is mathematical modeling. You have been asked to define carrying capacity. Carrying capacity, we know, is nature's capacity to support a given population, because nature can support only a limited number of individuals per species, and that limited number is called the carrying capacity. And then you have to derive the logistic equation, writing the compartmental diagram and balance equation and all that, word equation, balance law, and so on, and then find its solution also. So again, this question is also from the exercise of Barnes and Fulford, and we know that the answer is 2,40,000 e to power 3.5 approximately. So you can verify this again. Question from the book, C part, again from the book. So all these questions are standard questions from the book. You can see that the model is given, epidemic model is given. You have to just use that model to do some calculations. This is smoke in the bar question, which has come as sixth question, standard question, everybody knows. This happens to be the most important question of modeling, and it's based on lake pollution model. We replicate the setting of lake pollution model to smoke in the bar setting to calculate that the wise time to leave the bar will be approximately after 10 hours. So that means around 4 a.m. it will be a good time to leave the bar. So that is what came here. And then the second part talked about equilibrium position. So for equilibrium, we know that dx by dt, the rate of change is 0. So we have to also discuss stability. Stability, we know, stability of the equilibrium positions are discussed after calculating the derivative at the equilibrium point of the right hand side, and if the derivative is positive, then you say that it's unstable, and if the derivative is negative, it's a stable equilibrium. So all that can be done here. Again, and the next part was from epidemic model, and you had to consider chain rule to find a relationship between. So this is again from chapter number 6 of Barnes and Fulford, a question which is a typical question from modeling, and you know that its phase plane is sketched like this. It's dependent on gamma by beta line. So those who have done modeling nicely will know. So if this is gamma by beta, so let me make a proper sketch here. So so if this is the s-axis, this is the y-axis, and this is let's say s equal to gamma by beta, then here the trajectory is going to take this arrow position, and here it's going to take this arrow position. So it's a standard question from modeling again. So this was the 2023 paper, very much predictable, very easy, very much expected. All the questions were standard questions from the textbooks which have been recommended. So that is all. In the next video we are going to share the next paper, 2024 paper, for your reference. Thank you so much for watching.